This is Euclid Book 9, proposition number 35. And keep in mind that after this proof is over with, we have just one more proof, and then we proceed on to Euclid Book 10. And then we can start with three-dimensional proofs. And I tell you what, that's going to be some real fun. Okay, there are 101 proofs. That's right, 101 proofs in Euclid Book 10. So we're going to be at it for a while. All right, let's get this one over with. You wouldn't think that 4 little lines like this would be very complicated. Guess again. Let me read this to you. If as many numbers as we please be in continued proportion, and there be subtracted from the second and the last numbers equal to the first, then as the excess of the second is to the first, so will the excess of the last be to the all those before it. Okay? I didn't get that right off the bat, so let me show you this. Let there be as many numbers as we please in continued proportion, A, B, C, D, and E, F. So now what we're going to say is, as A is to BC, so will BC be to D, and D will be to EF. That's what we're saying. Beginning from A as least, and let there be subtracted from BC and EF the numbers BG and FH. Now you said they go, what? Okay. So now we're going to say that BG here, see this BG? It's A. We're also going to say that HF is the length of A. Okay? That's what we're saying. I say that as GC is to A, so as this length is to A, so is EH, which this is this length right here, EH is to the sum of, okay, notice how I said this, as EH is to the sum of A plus BC plus D. Okay? So we add these three numbers together, and then we say that that sum, EH is to that sum. That's what we're saying. Okay? For let FK be made equal to BC. So now we have FK. FK is right here. FK is going to be equal to BC. Those two lengths are exactly the same, or they're supposed to be anyway. And FL is going to be equal to D. Alright? FL is going to be the same length as D. Okay. Then, since FK is equal to BC, and of these, the part FH is equal to the part BG, so now we're saying that FH here is equal to BG, which is this one right here. Therefore, the remainder HK is equal to the remainder GC. So HK is going to be the same length as GC. And since as EF is to D, EF is to D, okay, so is D to BC. So as EF is to D, so as D is to BC. We got that. And BC is to A. So as EF is to D, so as D is to BC, so as BC is to A. We got that part. While D is equal to FL, so D is the same length as FL. Already said that. And BC is the same length as FK. BC, FK, they're the same length. And A is the same length as FH. A is the same length as this. Therefore, as EF is to FL, as EF is to FL, okay, following this so far? So is FL to FK. So FL is to, hold on. Okay. So is FL to FK. So FL is to FK. Okay, we got that. And FK to FH. So FK is to FH. So those are all three proportions. Separando, as EL is to FL, as EL is to FL, so is KL to FK. So is KL to FK. And KH to FH. As KH, no, wait a minute. Yes, as KH is to FH. Those are all ratios. Okay? Therefore also, as one of the antecedents is to one of the consequents, so are all the antecedents to all the consequents, and this is by Euclid Book 7, proposition number 12. Now comes the real fun. You might write some of this stuff down, because you're going to need it. Therefore, as KH is to FH, as KH is to FH, so are EL, LK, KH to LF. Okay. So EL is to FL, as EL is to FL. Okay. KL is to FK. KL is to FK, which we just said. And KH is to HF. As KH is to HF. We already said that. But KH is equal to CG. KH, GC. They're equal lengths. FH is equal to the length of A. Okay. And LF is equal to D, FK is equal to BC, and HF is equal to A. Got all that? If you don't, this stuff is online, so you can find this out for yourself. Therefore, as CG is to A, so is EH is to D, and BC is to, oh, I'm sorry. Alright, back up one more time. As CG is to A, so EH is, okay, this is EH right here, EH is to the following sum. D plus BC plus A. Therefore, as the excess of the second is to the first, so is the excess of the last to all those before it, which is what we were trying to prove. I know that's a rather long and complicated proof, but I'm sure if you plug in the numbers, it'll make sense real quick. Alright, I will tell you more in a future video. Stay tuned.